Hello students, welcome to today's class. In our today's class we are going to see applications of factor theorem from exercise 2.4. Determine which of the following polynomials has x plus 1 a factor. So before getting into the problem, let us see what is the factor theorem once again. Here if you observe a factor theorem here, if p of x is a polynomial of degree greater than 1 and a is any real number, then x minus a is a factor of p of x if p of a equal to 0. That means let us suppose p of x equal to ax square plus bx plus c. This is a polynomial. Now in this polynomial we have substituted a value. Let us suppose x equal to a. Now p of a equal to 0. That means after replacing this a value in x, if the result obtained is 0, then we say that x minus a is a factor of p of x. This is called factor theorem. Okay, so what we have to do, we have to substitute the value a real number in place of x and the result obtained is 0. Then we say that x equal to that value is called as a factor of that polynomial. After taking out this a to this side, we'll get x minus a. So we'll say that x minus a is a factor of p of x. Now coming to the problems here, determine which of the following polynomials has x plus 1 as a factor. We have to check whether x plus 1 is a factor of the given problems here. What is the first problem here? P of x equal to x cube plus x square plus x plus 1. This is a polynomial. Now we have to check whether x plus 1 is a factor of the given polynomial p of x or not. Factor or not. How do we know that? Just we have to replace p of x, we have to replace x with the number x plus 1 equal to 0 and x equal to minus 1. So that means we have to replace x with minus 1 and the result obtained is 0. Then we'll consider x plus 1 is a factor of polynomial p of x. Now let us see first problem. In first problem, p of x equal to x cube plus x square plus x plus 1, and I am taking x plus 1 as g of x. G of x equal to x plus 1. Now first find out x value from the g of x, that is x plus 1 equal to 0. That implies x equal to minus 1. Taking out this plus 1 other side, it becomes minus 1. 0 minus 1 is minus 1. Now p of minus 1 equal to, so substitute in place of x, minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. Minus 1 cube is minus 1 plus minus 1 square is plus 1. Plus into minus, here plus into minus will be minus 1, again plus 1. Now if you observe, minus 1 and plus 1 gets cancelled and minus 1 plus 1 get cancelled. So remainder is 0. That means the final answer is 0. So we can say that x plus 1 is a factor of, therefore x plus 1 is a factor of x cube plus x square plus x plus 1. Now let us say second problem. In that, let us take p of x equal to x power 4 plus x cube plus x square plus x plus 1. This is a given p of x, and g of x will be x plus 1. Now again we have to find out x value, the same process, x plus 1 equal to 0. From this, x equal to minus 1. Now p of minus 1 equal to minus 1 power 4 plus minus 1 power 3 plus minus 1 power 2 plus minus 1 plus 1. This will be minus 1 power 4 will be plus 1, minus 1 power 3 is minus 1, again minus 1 square plus 1, here plus into minus, minus 1 plus 1. Now let us cancel it. Plus 1 and minus 1 gets cancelled, plus 1 and minus cancel. Now final result will be 1, which is not equal to 0. Not equal to 0. Therefore x plus 1 is not a factor of x power 4 plus x cube plus x square plus x plus 1. Now look at third problem, that you can do it yourself from the exercise 2.4, first Roman third problem, do it yourself. Okay, now I am telling you fourth problem. Here also we have to find out the x value, x plus 1 equal to 0, x equal to minus 1. Now let's find out p of minus 1 here. P of minus 1 equal to minus 1 power 3 plus, sorry it's minus 1 power 2 minus 2 plus root 2 into minus 1 plus root 2. So after simplification we'll get minus 1 cube is minus 1, minus of minus 1 square is plus 1, minus into here minus into minus will gives us plus 2, 1 into 2, 2, 1 into again root 2 will gives us plus root 2, plus root 2. Now minus 1 plus into minus, minus, here plus into minus, minus, minus 1 plus 2, minus 1 will gives us minus 2 plus 2 plus root 2 plus root 2, plus 2 and minus 2 gets cancelled, we'll get root 2 plus root 2, 2 root 2, which is not equal to 0. Therefore x plus 1 is not a factor of x cube minus x square minus 2 plus root 2 into x plus root 2. This is first Roman. Now let us see second Roman. Now coming to the second Roman, use the factor theorem to determine whether g of x is a factor of p of x. In each above, p of x is given 2x cube plus x square minus 2x minus 1, and g of x is given x plus 1. p of minus 1 equal to 2 into minus 1 cube plus minus 1 square minus 2 into minus 1 n minus 1. 2 into minus 1 cube is minus 1 plus minus 1 square is plus 1. Minus into minus here will gives us plus 2 into 1 is 2 minus 1. Now 2 into minus 1 is minus 2, plus into plus is plus 1 plus 2 minus 1. So minus 1 plus 1 cancel, minus 2 plus 2 cancel, so the final answer is 0. Therefore we can say that x plus 1 is a factor of p of x, that is 2x cube plus x square minus 2x minus 1. In the similar way we have to do second problem also. Here first what we have to do, g of x must be equated to 0, that indicates x plus 2 equal to 0, that implies x equal to minus 2. Now we have to replace x with minus 2, so that you will get the result. That will be, if that comes as 0, then we say that x plus 2 is a factor of given polynomial, or else it is not a factor of given polynomial. So you do it yourself. Now see the third problem. Here also g of x equal to 0, x minus 3 equal to 0, x equal to 3. Now we have to substitute 3 in place of x in the given polynomial. So if the result obtained is 0, then we will say that x minus 3 is a factor of the given polynomial. If not, we will say that it is not a factor of the given polynomial. So this is also you do it yourself. So first Roman was done, second Roman was done. Now let us see third Roman. Find the value of k if x minus 1 is a factor of p of x in each of the following cases. So in the previous two Romans it is given that check whether x plus 1 is a factor of the given polynomial or not. There it is not given that x plus 1 is a factor. They ask to check whether x plus 1 is a factor or not. But in this problem it is clearly given that x minus 1 is a factor of p of x. Then we have to find out the unknown value of k. Now coming to the factor theorem again, till now we have done problems basing on first condition, that is x minus is a factor of p of x, then p of a equal to 0. We used this concept. Now in this third Roman we have to apply this concept, the second concept, that is p of a equal to 0 if x minus a is a factor of p of x. So in this Roman we will use second condition of the factor theorem, that is p of a equal to 0 if x minus a is the factor of p of x. So coming to the problem, here x minus a is nothing but x minus 1. X minus a is nothing but x minus 1. If x minus a is a factor of p of x, here in the question, if x minus 1 is a factor of p of x, so what should be the condition? What should be the condition? P of a equal to 0. That means p of 1 should be equal to 0. If this happens for this one, for this one, for this one and for this one, we'll say that then x minus 1 is a factor of polynomial. So now we'll use this condition to find out the unknown variable k. The first problem, p of x is given x square plus x plus k and x minus 1 and x minus 1 is a factor of p of x. Factor of p of x, that is given. So we have to check the condition p of 1 equal to 0. That means indirectly it is given a condition that p of 1 equal to 0. So now in x I am placing 1. So we'll get x square plus 1 plus k equal to 0. This indicates 1 square is 1 plus 1 plus k equal to 0. 2 plus k equal to 0. Taking out 2 to the other side, we'll get k equal to 0 minus 2 is minus 2. This is the answer for the first problem. So let us solve second problem now. P of x is given 2x square plus kx plus 2 and x minus 1 is a factor for the second problem. That means x minus 1 equal to 0. That indicates x equal to 1. Now p of 1 should be equal to 0 as x minus 1 is a factor. So two into 1 square plus k into 1 plus 2 equal to 0. 2 into 1 square is 2 plus k into 1 is k plus 2 equal to 0. K plus 4 equal to 0. That indicates k equal to minus 4. So the unknown variable k equal to minus 4. This is how we'll find out when a factor is given for a polynomial and they ask to find out a unknown value. Okay, so the remaining two problems you try it yourself. We'll continue in the next class. Thank you all.